Welcome to our talk on Analytics Improved, using cloud technology to improve performance. So just some introductions. Good afternoon, I'm William Try, I'm a Managing Consultant with DMW Group in the Business Transformation practice, and I've been looking at how to unlock the business potential of analytics by moving analytics platform to the cloud and looking at the end-to-end business processes of that. My colleague Josh Nicholson will talk, a principal at DMW Group will talk in a moment, a little bit later on, about the technical solution and about our progress through the project. So you'll hear from Josh shortly, but I'll just take you through this first part of the talk. So by way of introduction, we're DMW Group. We provide advisory, delivery and engineering services across digital, data and cloud technologies. We work with clients across financial services, energy and commercial and public sector. And the example we're talking you through today is from one of our public sector clients and pieces of work. So with that in mind, the scope and the potential of what we're trying to do here. So it happens to be in public sector, but this is applicable and transferable to other organisations in other sectors. The coronavirus pandemic clearly highlighted how much can be done when data is joined up and linked beyond functional silos that it might have previously serviced. And doing that quickly and turning around analysis in increasingly fast timescales has become really important to a lot of organisations, and that's something that we've seen certainly with our client organisation, as alluded to in this national data strategy paper that's recently been released. So there's some examples that have come out of the last 6 months or so that we think are applicable to other sectors, but within the public sector itself, it will be an exemplar for how to link data and improve analysis across a number of organisations, and that's something that we think is really applicable at this point in time. So just narrowing in on the particular programme that we're talking through here today, the solution is to have overcome some challenges around an analytics platform for a large government department to provide insight and analytics on a key government service. So the key transactional service backs off to an enormous data and analytics platform, which offers insight to a wide variety of users, as we'll talk through in a moment. The use of that platform has increased significantly over the last months and couple of years, and it holds a lot of data, and it needs to hold historic data for up to 25 years. And that's in common with many reporting and analytics systems that organisations will have. It's directly used by over 300 analysts and data scientists, and that community of people is just increasing over time as people find the platform and find the insight that can be derived from it more and more useful in a variety of different use cases. There are 3,000 other users that use traditional data warehouses or export data from this platform to do a variety of things around producing official statistics, from looking at performance tests of different treatments of interventions. So if we apply an intervention, how does that perform in the field versus the group that haven't had that treatment applied, and gaining that insight quickly so it can be implemented and rapidly transitioned into a scalable solution is really important, and that's something that we've sought to unlock with our work on this programme. It's also used retrospectively to detect and to prevent fraud, which we're able to, as we talk through the solution, move to an increasingly real-time basis. So rather than it being a backward-looking historic review of what's happened, it becomes an in-the-moment detection of triggers and detection of patterns of behaviour. So the organisation had a number of challenges that I want to just allude to here. They have a fixed amount of hardware on premise, so that becomes challenging as the data volumes just increase and the usage of that platform becomes ever more intense. The fixed hardware and the fixed infrastructure becomes a limiting factor on performance, resilience, etc. It was built originally in this particular example as a proof of concept, but it's now running a full live service, and therefore there's some contention that platform is experiencing. Underneath that, underpinning it, there's some hardware that's reaching end of life and the architecture is challenged. And some of the processing that's taking place on that platform, for example, an overnight batch job that takes an increasing amount of time as the data collections increase in size and increase in complexity and have more to compete with as they're running, with jobs being run out of hours, for instance. There are customers or users that are uncertain of the level of support that they're able to access. As I mentioned, the platform, sometimes these things arise out of a proof of concept and they become very useful, but a service wrap and the management processes that go around that are really critical to ensure that users feel like they're being treated as users and customers of a service, and doing so allows them to then unlock more value from the platform. There's a bunch of complex data governance processes and impacts as a result of interdependencies across the data supply chain. So impacts downstream and upstream of changes are felt in the data schema, and impacts on data products and other things that have been created or instantiated off the back of that data pipeline. So there's quite a lot of complex data governance that we've needed to understand some of the impacts of that, so we can remediate and remove that set of impacts by moving to a more stable platform and take advantage of the functionality of a more robust data pipeline, as Josh will talk through later in the talk. And clearly there's a lot of data schema changes happening when you've got a data set that's this big, that is this critical, and is changing a lot during the last few months. There's a lot to impact assess, and a lot of schema change driving impacts downstream in the value chain and the supply chain. So they're just a flavour of some of the challenges that organisations typically encounter with an analytics platform that's running hot, that's become really useful and people are deriving a lot of value from, but we now need to take a step change to unlock the value and improve the analytics that's possible to be derived. So we took a focus on looking at the customer experience, and I believe that's really important so that the users understand that they're using a live service, they're subject to potential service management processes, and they could take advantage of feature development that will put them in the driving seat. So it was really important to agree on a vision and drive some principles to achieve that. So within the organisation and within the teams of users, we've looked at agreeing some priorities there. So the principle of having less friction and greater autonomy in accessing data, so that we free up folks to be able to drive true autonomy in accessing data and doing what they need to in terms of creating data pipelines and creating data products. Driving faster access to data so that it can unlock decision making and drive improvement into the overall end service that this MI is running on, and this analytics platform is running alongside. And ultimately innovating and driving decisions informed by data that allows better interactions with customers and better decisions over resources, over priorities, and over service enhancements that are going to be made. So there's a number of things there that allow us to drive an improvement in customer experience that's beyond just where the analytics platform is hosted and the infrastructure, if you like, of underneath that. A second point that's really important as part of this programme of work has been to understand the business requirements of what those users have needed to achieve. Increasingly over time, if someone's constrained on an on-premise platform, their use cases can themselves become constrained, and their footprint sort of diminishes over time as they schedule jobs that are smaller, that try and run out of hours potentially, or try to minimise the impacts of having contention over a large platform. Ultimately, the customer says, I just need the data. They only want that data, and then they want to get in, out as quickly as possible. Engaging the user in a dialogue about the requirements and understand what value add could be provided to getting that data faster and more reliably, certainly, but what other features could be useful to them helps drive priority proof points for us to achieve, and whether that's in an alpha proof of concept environment or whether that's in a production build, it helps guide the development to be really responsive to what the user's needs are today, rather than what they might have been at the start of using an on-premise platform. Which builds into my next point around, this is about business change as well as platform change. So moving an analytics platform, as in this case, from on-prem to the cloud, fantastically improves the technical capability of the organization, but it gives a chance to look at the end-to-end business processes and say, actually, is this being serviced in the right manner and in the right way? So we expanded services to better support users in the first instance, so providing service management processes that were consistent and that allowed them to understand what the service was delivering to them in terms of uptime and reporting. But secondly, we then had a conversation with them about, given that level of service, what could be potentially improved about the business outcome that you get from this particular platform or from the service that you're receiving. And the third point is to get some requirements and then get out of the way and prove some value early. So we've used those requirements to inform and drive an alpha prototype that allowed us to go back to some of those representative users in the community and start to demonstrate and road test some scenarios that would then say, right, these are priority features that on your current on-prem environment are challenging to achieve or just not possible, but in the cloud it's entirely possible, and actually some of those requirements may get, or some of those features may get prioritized in the production build ahead of other things. So that proof point early for folks who are using the platform has been really important to us. So if I just move on to describing a little alpha phase that we did for this particular program, we were able to demonstrate the fundamentals first. So the ability to run ad hoc and repeatable scheduled queries and effectively replicate what the organization was experiencing with their on-premise environment, but to do so with much faster turnaround times and much more effective and predictable query loads. That was really important to establish that proof point early, and we did this using 5 2-week sprints to spin up an alpha prototype that would validate some of these needs. The second point was to work with data science users and look at their sort of principal use case, that is to collate data, analyze it, and then create models and understand how they then federate those models out within the organization or with other organizations. That principle of unlocking value and sharing data beyond maybe functional silos, again, allows you to prove some value that absolutely critically moves the conversation on to, right, so how do we implement this in live, in the real environment? The third point in this alpha phase was to prove or demonstrate business efficiency through the use of improved tools and automation. So as Josh will come on to talk about, some of the tooling and the automation that you can apply clearly is one of the principal reasons that you would move this type of functionality to the cloud, but using some of the technology and demonstrating that really quickly in a rapid sandpit environment was fundamental in moving the conversation forward and demonstrating value. And as a byproduct of doing all of those things, you build a community and energize customers that are now aligned and aware of the program vision, and they have started the journey of change in moving their analytics platform towards the cloud, and validated some early needs can be met by doing that. So an early proof point through an alpha phase has proved in our approach really, really important to help move that conversation forward. So that's some understanding of the work that we've been doing with the business and with the organisation to help prepare them for that move. My colleague Josh Nicholson is now going to talk a little bit more about the solution that we have used with this organisation.
Thanks very much, Will. Just checking I've come off mute correctly there. Hi, so I'm Josh Nicholson. I'm a principal at DMW, and I've been working for the last 5 years across big data programs in public sector, but also in private sector. So I'm going to be talking to you a little bit today about the solution for this particular client, and what we managed to achieve there. So first of all, I kind of wanted to talk about the case for cloud. You heard from Will about some of the issues with the on-prem platform. A lot of these will be fairly standard case for cloud type things, but I think it's important to sort of walk through them. One of the key requirements we had was to retain the data for 25 years, and to do that in a highly durable way, which obviously AWS, so Amazon's cloud solution, is able to help us with. I'll talk a little bit later about some of the retention period and some of the challenges that can cause. We also had, we had uncertain data volume growth. So currently streaming about 5,000 transactions a second. That's 1 gigabyte of data every 4 minutes. So it's quite a lot of data we're streaming, and we need to be able to ensure we can scale that when spikes happen. So obviously the recent COVID crisis has caused massive spikes in data that we need to be able to deal with. And on an on-prem solution, obviously that's very hard to achieve without having a lot of spare capacity in your back pocket, which costs a lot of money, or very short cycles, but it's normally quite hard to get stuff into a data center that quickly. Following on from that, not just the storage, but the compute being able to be burstable is extremely helpful. So we have regular peaks in our workloads, weekly, monthly reporting cycles, which would benefit from being able to spin up a bigger cluster and then being able to spin that down when the reporting workload decreases. But we also have ad hoc peaks. So COVID has caused the need for data analysis for certain areas to increase, and for answers to be required over very large data sets very quickly, which the cloud is obviously perfect for that. And then new questions and new architectures is a really key benefit as well. So the cloud providers, AWS, Azure, Google, etc., are at the forefront of innovation in this industry. So being in a position to be able to take advantage of whatever new technologies haven't been invented yet, but undoubtedly will be invented very soon, it is really helpful for the future. And it also helps retain the best talent and things like that. People want to work on these kind of cutting edge technologies. And of course, we're aligned with the government's cloud first policy. So cloud first remains policy of the UK government, ensures data is stored and secured and efficient, and aligns with a lot of other government departments as well. So I'm going to walk you through the high level technical solution. Don't worry, there aren't any architecture diagrams, but I have gone a little bit icon heavy. So firstly, data ingest and storage. So we're streaming data in from our source system. This is obviously a change to our previous architecture, which was a batch architecture where we were taking a batch feed overnight. This literally we're streaming in every single message change on the source system. So you can imagine that's quite a large, complex application, and we're streaming in all of the changes live as that happens. That's deployed on an EC2 instance, which is essentially just a compute box that you can buy. We're then streaming that into Apache HBase. HBase is a time series database, so it's excellent at streaming data in and lots of different versions of data, and it can store infinity versions if you give it enough space of each record. So what that enables you to do is very, very quickly pull out a time sliced version of the entire data set. So I want to see the status of the data as of midnight yesterday. That's a really easy operation to perform on that kind of database. That's been deployed backed off to S3 storage, which is obviously the standard storage in AWS and reasonably cheap and very durable. If we move on to data pipelining and processing, we're using a number of technologies here. I think the main one really being AWS EMR. So EMR stands for Elastic MapReduce, and is essentially Amazon's Hadoop offering. So it's a Hadoop, open source Hadoop deployed as a service, which Amazon provide to you. So you can spin up EMR clusters over the top of your S3 layer, and then have a big data environment available to process. This also separates out compute and storage. So storage is on S3 and compute is in EMR. That's a difference between an on-prem solution where your storage and compute are co-located. So if you have really high storage requirements but very low compute requirements, you're going to be wasting a lot of processing power. We also have Lambdas, EC2 instances, and Glue as well, where we try to use serverless technologies like Lambda where we can. So instead of spinning up an EC2 instance to do something, if we can get it done in a Lambda much faster and quicker, we'll do that. A Lambda, for anyone who doesn't know, is just you tell AWS you want to run some code, and it just runs it anywhere it likes. So you're telling it what you want it to do. You're not telling it where, and you don't have to worry too much about setting up the right config for those boxes. You just say, I want to execute this code, and it does that. So we use a lot of those for smaller processing tasks that might take a few seconds and things like that. Analytical tooling, then we obviously users will use EMR clusters to run their code on. They're writing things in Spark and Python. We're using Hive as well, and sort of Hive query language so users can access it almost like a database. And then they're using Jupyter and RStudio as the kind of front-end tools to access the platform. All of this is accessed through AWS Cognito, which is essentially a remote desktop type solution. We are essentially deploying containerized environments for each user. So what that means is when I log in via my remote desktop, I get my own instance of Jupyter, and it's completely separate from anyone else's instance. So in a security sense, that's a very secure way of doing it, because I can't do anything with anyone else's instances, and they close down at the end of the day, so then they're not running consistently, and I only get access to the data that I'm allowed to get access to. And then we've got a bunch of supporting technologies underneath. Data encryption and security is obviously very important. We're storing this data for 25 years, so we need the crypto that we use to be able to stand up to attack for 25 years. So we're using Cloud HSM. So an HSM is a hardware security module. So one of the only times in the cloud where you actually buy a physical piece of kit, really. So we're buying our own physical hardware security module that isn't shared with anyone else. And that generates a really secure key for you, something that's far more secure than you can generate in software. So it generates a really, really very good random number, essentially. Well, obviously, we're using double key encryption here. So Cloud HSMs are expensive. So we don't want to put all of our data through there, because that would become a bottleneck and become very expensive. So we encrypt our data payloads using software security keys generated, and then encrypt that key with the Cloud HSM. So in that way, you kind of get the protection of the extra secure Cloud HSM, but you also get the speed of being able to decrypt things in software. You can deploy this as a layer around EMR that's essentially transparent. So the user, when they access EMR, has absolutely no idea that they've just decrypted and encrypted the data on the fly. They never ever store anything unencrypted. It just flows through that transparent layer. We didn't find that added too much in terms of speed degradation, so the performance is absolutely fine. Monitoring, alerting, and metrics. Obviously, deploy, monitor everything, put alerts on everything we can, and then create some dashboards in Grafana. using a lot of the standard tooling you'd get there. And then another key area is our DevOps and automations. So we deploy everything infrastructure as code by a Terraform. So anything can be ripped down, started up again anytime we like. And we do that on a fairly regular basis. So in terms of disaster recovery, it's very easy to just spin the whole thing up again from scratch. Our automated deployment pipelines are very quick, so we can deploy to production multiple times a day, and you can get something from dev all the way through our 5 environments in about 5 minutes if it's a small change. So, and that will go through a number of automated tests, regression testing things. So it gives engineers the confidence that they can deploy things to production a lot more often and a lot smaller items, because they kind of have that confidence that it's gone through all of the levels of testing. If I move on a little bit, one of the things we try to achieve here, which when we're moving from on-prem to cloud, is separating out our concerns. So there are a number of issues that were created by the legacy architecture. So data pipelines, business critical processes, and ad hoc queries all competed for the same finite compute. So everyone was trying to get their slice of the pie at the same time, and this obviously caused an extremely high level of contention. So we wanted to try and avoid that. We have had instances where one user query has taken down the entire cluster essentially because it was poorly formed and just able to run. So those things are quite disruptive. And of course, you've got the extremely the ramifications of someone doing something wrong could be quite high. So you don't want anyone to accidentally drop all of the tables. That's obviously not going to be very good. So with our new design, we created ephemeral clusters which are tuned to workloads. So we process the batch processing to create some data sets that data analysts will use, spin up their own EMR cluster, create the data set they need, and then destroy the cluster. And so that's how our batch processing works. And then for analytics itself as well, we have a number of, or the idea of a number of clusters. So you might have a playground type cluster where your data scientists can test a few things out, and they've got access to potentially prod-like data, but isn't prod data. And then when they want to sort of promote that, they can then go to the next environment where they can test it out on real live data, but they can tweak their algorithms in the sort of prod-like data environment. And then once they are happy that that's kind of a thing they want to run on a regular basis, then we'd promote it to a more production-like analytics environment where it would run and no one would be able to touch it. So you can't accidentally start changing things that a report relies on, but you do also have the ability to spin up new environments just to try something out that you weren't sure about. So it gives a lot of stability, which obviously reporting teams need, but also gives the data scientists all the flexibility they need to try out new and cool ideas. And then the containerized user workspaces obviously helps create separation. And if one place fails, then the failure is isolated to one person. So if their Jupyter instance has an error, then Jupyter doesn't fail for everyone. It just fails for that one person, and they're able to restart it. So every time they log in the morning, it essentially is going to spin up a new Jupyter instance for them, and load all of their data and saved queries and things into it, and then destroy that instance when they log off for the evening. Wanted to talk a little bit through some of the numbers, because there's some quite big numbers involved. So I mentioned 25 years. We're currently seeing 96 million events in a day. So if we assume a 5% year-on-year growth, which is probably on the very low side, we're going to end up with 1.67 trillion records, which we're storing over a 25-year period. So you may know that AWS durability is quite famously 11 nines. So that's 99.99, so 11 of those 9s of durability. So, but that does mean over that time period, we're going to lose 16 records. So 16 records doesn't seem like a lot out of 1.67 trillion, but you can't lose them, right? So this is the corporate memory. So we had to build in place replay mechanisms such that we, if things go wrong with the data, we can replay it from another source. So, and then HBase is obviously technology we chose to use this. It scales very, very well to handle petabytes of data, and that's backed off to S3, which obviously is very highly scalable as well and can be replicated across multiple regions, such that if you suffer, AWS suffers a region outage, your service shouldn't fail. I think there was a region outage or an availability zone outage in the last couple of weeks, and we didn't see. Obviously, it wasn't perfect for us, but we didn't see the service fall over. We saw sort of a graceful failover. So talk a little bit about how DMW helped. So we provided architecture and cloud engineering services. So we architected and built the AWS solution. We utilize Amazon services where possible and serverless technologies where possible as well. So that's always our first thing to try. And if there's only a good reason not to use one of those, we'll look at something else. So I think this gives us the advantage that, if you use an Amazon service, you don't have to feed and water it. You just get the service and you can do what you want to do. So you're only adding value and customization where you need to achieve the job you need to do. We have started to introduce a data ops operating model. So looking at a collaborative approach with data scientists. So they become more than just users of our platform. So we're sort of trying to blur the lines between the platform team and the users, such that we're, not just delivering a service, we are integral to the way they work. So as data scientists become more au fait with the AWS service offerings, they may want to play around with some of the new innovative features, and we might want some of our platform engineers to be much closer to those data scientists, helping them on a day-to-day basis achieve the business value that they need. And then we've documented products and services approach as well, such that it's clearer what we're offering, rather than saying, we offer a big data platform. We are talking about the product and the service that we're offering, rather than just the technical architecture. And then we've instilled and worked with the client being advocates for Agile and DevOps. The client was obviously quite keen on this anyway, but I think this has really helped us achieve this in the fastest time possible. So the fully automated pipelines that we have, as I said, deploy to production in 5 minutes, but having gone through all of the very, very secure quality testing. So that gives a lot more confidence for engineers that they can deploy things like that. If they don't have that, they're a bit wary about making changes, and that can slow things down. We don't have any testers on our team. As such, we state that quality is everyone's responsibility. So we do have test SMEs, people who have got sort of that more testing mindset, but they're no different from the other engineers, other than that they're sort of there for people to check things with. So testing is built into absolutely everything we do. Similarly, secure by design, it's a term that gets bandied around quite a lot. I don't think I've ever been in a team that's actually achieved it, except this one. So the way that has been achieved is by having an embedded security architect in the team. And over time, what that does is all of your engineers start to think like security architects. So if they're thinking every time they're designing something, well, I've got to run it past my security architect, and I know he's going to say X, Y, and Z. Well, they just don't even ask him anymore. They just do X, Y, and Z. And then they check it with him, and it takes 5 minutes to check, and they go, yep, signed off. So we've got no sort of long drawn out security sign-off processes, because the team is trusted to be securing things by design, which has taken, several months, a year or so to sort of gain that trust. But we are, that is how we've achieved that. I would say we're working towards privacy by design, so we want to get to the same thing. So when our engineers are thinking like testers, thinking like security architects, and thinking like privacy advocates, then we've kind of cracked it all. But that one's a little bit harder, and will take a little bit longer. And then we've used Scrum and Kanban interchangeably sometimes over the years. Switched to Kanban recently. We feel like that gives us a little more ability to sort of change approach quickly and pivot. So in terms of benefits, faster access to operational data is the key one. So, and faster decision making. So obviously, as things like COVID happen, if you've got access to the data that was a couple of hours old and fast and analytics on that data, you can make much better decisions. If you're having to wait 2 or 3 days or a week, then obviously your decision making is out of date. Resilient, scalable, safe, etc., but also innovative, as I mentioned, with following the cloud providers. Improved ability to manage costs, so capital spend reduced and instead operational expenditure. There's a lot you can do to manage your cost within the cloud. I would say if you just port your on-prem thinking to the cloud, it will not be cheaper. But if you think like you're supposed to in the cloud and think about spinning things up and not having compute environments just there, then you can achieve some quite good cost reductions. And then a lower amount of bugs and a more stable platform because of our testing and automated deployment pipelines. And then of course, aligning to the government tech strategy, I think helps build critical expertise in-house. So you want to be able to take advantage of these cloud-based platforms. You need the expertise in-house to be able to do that. And we've been helping achieve that, such that when we leave, we've kind of left behind a legacy of people who can sort of take that forward and make use of all the new features that come out as AWS launched them. And finally, some key takeaways. So these are some things that I've learnt. Some of them might seem common sense, but I always think it's quite good to look back on a project and think, well, what went wrong and what do we learn here? I think the top one for me is actually really, really key. So an analytics platform always becomes operationally critical. A lot of companies will think of analytics platforms as not as critical as the operational platforms. And that's true. They're not as critical as the front end operational pieces, but eventually with the amount of data they contain and the amount of analytics that happens, you will find over time, and probably without noticing it, that more and more critical business processes actually rely on the analytics platform. And therefore, if it were to go down, you'd suddenly find quite a lot of things don't work that you maybe didn't know were reliant on that. So I think that's just a learning to essentially make sure that as critical things are developed, that you know which ones they are and put in place the right support mechanisms. That's obviously a bit easier to do in the cloud technically, because you don't need to have a whole new data center ready. You just spin things up and have hot standbys. So it's easier to provide that sort of 5 nines availability in the cloud, but you also want to make sure you provide the support models that might need weekend working or something like that. The next one is about a paradigm shift, I think, for both technical teams and users. Switching from on-prem to the cloud is a shift for them in terms of thinking. A lot of people will just move their thinking to the cloud and end up just spinning up servers and then end up taking full advantage of being able to have ephemeral clusters. And that requires users to think very differently as well as technical teams. So a user can now make a decision to say, I would like my query to run in a couple of hours and I'll pay 20p for that. Or maybe I need it to run in 2 minutes and I can pay £1.50 for that. So not big numbers there, but if you multiply those up, obviously it can have a large impact on your cost, but also gives users a large amount of flexibility. So there's a lot to think about and to work through. And then probably not a surprise to anyone, but data testing is absolutely critical, especially when you're trying to replicate externally published reports. If you move to a new data source and you can't explain why suddenly the numbers have changed, then you're going to be in a bit of hot water. So we work with the principle of 100% explainability. So it doesn't need to be the same, but you do need to be able to explain why it isn't the same. And then streaming data is obviously another paradigm shift. So we haven't quite got there yet. We are streaming data in absolutely live, but we are micro batching it up at the moment. So we're providing, users are used to sort of looking at snapshots in time and backwards from there. So that's what we're providing at the moment, but it's on a journey. So most of our data is yesterday's data, but we are starting to produce some data sets that are updated 3 times a day or 4 times a day. And then you can start to move towards streaming, but that does require quite a lot of different technologies and quite a lot of different mindsets as well. And it's probably worth noting it's not necessary for all applications. So reporting and MI and things, you may not need streaming data, whereas fraud detection, you may want to try and detect that in line as it's happening and do something about it. So those are just some of the things that I've learned on the project, and that I think I will take forward into my future projects and valuable takeaways.
Thank you very much indeed for your time, and we hope you found this presentation useful, and look forward to seeing you at one of the other LDF events that DMW are hosting. Thank you.